Hi ladies, it's Mr. O'Sullivan. Today we're going to be doing lesson 6-2, the rectangle. And just a heads up, this is actually a DESMOS lesson that will be graded. So please make sure that you complete your assignment on DESMOS. That way you get your classwork grade, and then don't forget to complete your Delta Math assignment. And you're going to have unlimited attempts on the Delta Math assignment since I had to create the problems. Okay, so if there's any issues with them, just please let myself or Miss Colorundo know, and we'll reset it. All right. So today's learning target is I can analyze a quadrilateral side lengths and angle measures by using the properties of a rectangle. So what we're going to be doing today is we're going to be looking at this image a lot. Oh, let me draw it again. We're going to be looking at this image quite often, which is a rectangle, okay? So we're going to be looking at the intricacies of this image, or this, not image necessarily, but its shape, okay? Now let's go on to slide 2 of our DESMOS. By definition, a rectangle is simply a parallelogram containing one right angle, which is a little weird. So we're saying a rectangle is a parallelogram, which is a completely different shape, but we're saying that it has all the properties of parallelogram, and then one extra thing. It's got one right angle. But if you look at your visual, you have 4 right angles. So I have a right angle at D, an angle at A right angle at B, and then a right angle at C. And we know that right angles all measure 90 degrees. Okay. A rectangle has 4 sides, 4 vertices, 4 angles. If you look, I have angle, 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 angle. I've got 4 angles, and they're all right angles. One thing we know is that our opposite sides are congruent. So if I wanted to, I can say AB and DC are congruent, and I can also say AD and BC are congruent. So I can say that my opposite sides of a rectangle are congruent, which is a property of the parallelogram. I know my adjacent sides are perpendicular. So when we say adjacent, we mean next to. So AD is perpendicular to DC, DC is perpendicular to BC, BC is perpendicular to AB, AB is perpendicular to AD, and vice versa. I can even say in going backwards now. And remember, perpendicular lines create right angles, and we also know that our opposite sides are parallel. What I would like you to do now is basically rewrite one of these theorems or properties in this text box. That's all I want you to do. I just want you to rewrite one of those properties. So some theorems about Mr. Rectangle. There are 2 theorems. All angles are right angles. Diagonals are congruent. So if I want to, I can say that DB is congruent to AC. So my diagonals are congruent to each other. So my whole diagonal is congruent. Also, if you look, I do have a right triangle. I have a right triangle right here. And then I have a right triangle right here. So I can also use some Pythagorean theorem in some of these questions. Okay. So practice problems. Answer each of the following questions. Make sure you read the information. Just giving you a heads up if you do the DESMOS. Again, because you should. If you type your answer right here, it will give you the correct answer. Well, it won't give you the correct answer. It will tell you if you're right or wrong. I think it'll say, woohoo, or something. And then make sure that you attach a picture of your work right here. So I want you to basically click on this and then take a picture. Cha-ching! Or wait, no, that's when you get money. Screenshot noise or whatever. Okay? So draw a rectangle ABCD with diagonals intersecting at point R. So I'm going to draw a rectangle. So I'm going to draw a rectangle ABCD. And they're intersecting at point R. So I'm going to draw diagonals at AC, a diagonal at BD. I'm going to put R right in the middle. Okay. So if DR is 6, find AC. If you look, it's a little weird because I have DR, but if you remember, we know that all these pieces of the diagonals are congruent. So everything on the inside of my rectangle will be a 6. So I got a 6 here, a 6 here, and a 6 here. If you look, you want to find the value of AC. So AC is made up of 2 inners, as Miss Daniels would say. I've got a 6 and a 6. This is AC. So I can say 6 plus 6, and 6 plus 6 is 12. And that's your final answer. So I would put a 12 right here. And then I get like a check mark or something. Okay. Question number 1b. Draw a rectangle ABC with diagonals intersecting at point R. So I'm basically redrawing this image over here now. So I have my ABCD. I'm going to intersect at R. Very good. And now I'm going to label my image. So I know that AR is 3 times 4x minus 3. And DR is 10x plus 1. So I know AR is 3 times 4x minus 3. And DR is 10x plus 1. Remember, we know that these pieces are congruent to each other. We know that all those diagonals are congruent because the diagonals in a rectangle and a parallelogram bisect each other. So if I want to solve for x, I just have to set those two equal to each other. So I'm going to do 3 times 4x minus 3 equals 10x plus 1. Whenever I have a number on the outside of my parentheses, I got to distribute. So I'm going to distribute the 3 to the 4x and the 3 to the negative 3. 3 times 4x is 12x. 3 times the negative 3 is a minus 9, and that's equal to 10x plus 1. You want to get all your x's on one side of your equation, so I'm going to subtract 10x from both sides of my equation. And I get 2x minus 9 equals 1. Then I add 9 to both sides. And I get 2x equals 10. And then last but not least, I divide both sides of my equation by 2. And I get x is equal to 5. So now what I would want you to do is I want you to say, like, you know, AR is going to be equal to 3. Well, AR is 3 times 4x minus 3. But if you look, we did our distribution. We got 12x minus 9. So I'm basically going to just plug in a 5 for 12x minus 9. So 12x minus 9. So 12 times 5 minus 9. Well, 12 times 5 is 60. 60 minus 9 is 51. Now, CR, we know, is congruent to AR, so CR is also 51. DR, well, that's 10x plus 1, so we're just going to plug in 5 to 10x plus 1. Ten times 5 is 50. 50 plus 1 is 51. And then if you look, BR is also congruent to DR, which is also 51. So remember, we didn't even have to really do computations because we knew everything on the inside was going to be 51. Now, question number 1C. Draw a rectangle ABCD with diagonals intersecting at point R. If AR is 18 and BD is 2x plus 30, find x. So the first thing we're going to do is we're going to just draw our visual again. So I draw a rectangle ABCD with diagonals intersecting at R. Draw that visual. Just had to check my microphone was on 1 second. Okay, good. Now we know AR is 18 and BD is 2x plus 30. So if you look, we're saying that this whole segment is 2x plus 30. If you remember, if this is 18, then this is also 18. And we know our diagonals are congruent to each other. So I know that my diagonal is going to be 36. So if I wanted to, I can do 2x plus 30 equals 36. Subtract 30 from both sides of your equation. Get 2x equals 6, and then divide both sides by 2. And that's your final answer. And don't forget to put a 3 right here and attach your work. Okie dokie, artichoke. Question number 4. The lengths of the diagonals of a rectangle are represented by 7x and 5x plus 12. Find the length of each diagonal. Background knowledge. What do you know about the diagonals of a rectangle? Well, if you know they are congruent. So whenever I have something that's congruent, I just set them equal to each other. So I'm just going to set my diagonals equal to each other. So I'm going to do 7x equals 5x plus 12. Subtract 5x from both sides of my equation. So I get 2x equals 12. divide by 2, divide by 2, and I get x equals 6. So now that I know x is 6, and I know my diagonals are congruent, I can just plug it into one of them. So if I want, I can plug it into my 7x or my 5x plus 12. I'm just going to plug it into my 7x because that'll be easier. So both diagonals. So I just plug in 6 to 7x, and I get 42. So the lengths of both diagonals are 42. You just put a 42 in here. Our final set of questions. We actually have 2 more and then we're done. 1 more after this one. If zy is equal to 2x plus 3, so I'm going to label my image, so zy is 2x plus 3, and wx is wx, is x plus 4, determine the length of wx. Do not forget to attach your work. Well, if you remember, we know that the opposite sides of a rectangle are congruent, so we're just going to set them equal to each other and solve for x. So I'm going to do 2x plus 3 equal to x plus 4, take away an x from both sides, get x plus 3 equals 4, and then take away 3. And then I get x is equal to 1. Thing is, it wants you to find wx, so I have to go to wx and plug it in. So I just said x was 1, so I have 1 plus 4, and 1 plus 4 is 5. So I can say wx is 5. And then you attach a picture of your work. Okay. If the measure of angle ZYW is 2x minus 7 and the measure of angle WYX is 2x plus 5, then determine the measure of angle ZYW. So we want to find the numerical values. We want to find out it's like 20 degrees, 30 degrees, 40 degrees. We don't want to know it's, 2x minus 7. That doesn't really help us. So we go to our image and we're going to label it. So we're going to label our ZYW and our WYX. So the first thing we're going to do is this guy right here. So I start at Z, go to Y, end at W. So I have my 2x minus 7 right here. And then I have WYX. So I start at W, go to Y, and end at X. So it's going to be this angle right here. So I put my 2x plus 5 right there. Now, if you remember, these aren't going to be equal. They're actually going to add up to 90 degrees. So I'm going to take those angles, add them up, and set them equal to 90. So I have 2x minus 7 plus 2x plus 5 equals 90. First thing I gotta do is combine those like terms. So 2x and 2x gives you a 4x. Negative 7 and a positive 5 give you a minus 2. And that's equal to 90. Add 2 to both sides. Get 4x equals 92. And then do 92 divided by 4, which gives you 23. If you look though, it says find the value of angle ZYW. We know ZYW is 2x minus 7. So everywhere I see an x, I'm going to substitute a 23. So I have 2 times 23 minus 7. 2 times 23 is 46. Take away 7, 39. So angle ZYW is 39 degrees. So you're just going to put a 39 right here. And as always, don't forget, attach a picture of your work. If you have any questions, email myself or Miss Colorundo. Don't forget to do your Delta Math. Have a great day, ladies.